All right, ladies and gentlemen. Now that we've done a series circuit, we're going to go ahead and take a look at a parallel circuit. And I have kind of a different way that I like to do these, but we'll look at kind of both ways that you can do them. All right. So the first thing that we want to look at is what is our total voltage, and voltage total is given to us here. That's my VT. So I've got 12 volts to start. And the next thing I want to look at is what is my current total? I don't know it. What is my resistance total? And for a parallel circuit, this is the formula that we use. So I can just replace the R1 with 220 ohms, R2 with 470 ohms, and R3 with 1200 ohms. But when you put this in the calculator, you have to be very careful. You're going to, of course, let me see if I can get some light on here to make this a little bit better for you guys. All right, so maybe you can see it a little bit. You're going to do 1 divided by, and then I'm going to ask you to do 2 parentheses, and do 1 divided by 220, close that parentheses, add to it, open a new parentheses, 1 divided by 470, close it, add, open a new one, 1 divided by 1200, close it, and then close it again. And that gives me the total resistance, which my RT is 133.2188104 ohms. All right. And in sig figs, that would be 130 ohms, right? Or what would it be? 13 deca ohms, but we don't need to go there. All right, so I know my total voltage, I know my total resistance, so of course the next thing I'm going to do is look at my total current, and that is equal to my voltage total divided by my resistance total. And so it's going to be 12 volts divided by 133. I can't do the rounded value, I've got to do the whole thing. 2188104, which gives me a total current of 0.090077369, or in sig figs, that would be 9.0 centiohms, right? Or we'll call it 90 milliamps, not ohms, amps. So 90 milliamps. And here's the deal with a series circuit. With a series circuit, the currents are all the same. So I would just write that right there. But this is not a series circuit. This is a parallel circuit. And in a parallel circuit, the voltages are what stay the same. So you need to recall voltage total equals VR1 equals VR2 equals VR3. So that 12 volts I know is 12 volts here, 12 volts here, and 12 volts here. Everybody gets the same voltage, right? That means not everybody gets the same current. In fact, Kirchhoff's current law says that the sum of the currents equals the total current. So I know that IR1 plus IR2 plus IR3 should equal 90 milliohms. How are we going to figure out what I is? Well, we're going to use the exact same formula as we did there, and we're going to look at IR1, which is VR1 divided by R1. And in this case, voltage in R1 is 12, and R1 is 220. And 12 divided by 220 is 0.05454 repeating amps. So 54.5 or 55 milliamps. And IR2, we do the exact same thing. So 12 divided by 470 is 0.0255319 amps, or 26 milliamps. And finally, IR3 is 12 divided by 1200, which is 0.01 amps, or 10 milliamps. All right. So that's that. And what you can do is say 55 plus 26 plus 10 should equal 90. Of course, we're using round values, so it'll be a little bit off, but that's how we would check Kirchhoff's current law down here. And hopefully we're pretty close. It looks like we're 1 milliamp off. So just a matter of rounding. Nicely done. Thank you. And as always, ring that bell, punch that like button, and holler at your boy in the comments below. Thank you very much.